Now after tensile stress, let us have a problem based on compressive stress. Now you just look at that particular problem statement. There is a rattan rod which is subjected to compressive load of 350 kilonewton. If the permissible stress in the material is 52 megapascal, calculate the diameter of the rod. So it is a compressive load given, means compressive stress is induced. Now as far as given data is concerned, there is a load of 350 kilonewton and there is a permissible compressive stress of 52.5 megapascal. We have to find the diameter D. Compressive load is equal to force divided by area. Obviously same formula that we have to use, only the direction is different. When we say tensile and when we say compressive, one is positive, one is negative. As far as area is concerned, circular cross section pi by 4 d square is the area. Sigma indicates stress is equal to force divided by area is the formula, which is same as that of tensile stress. Now let us put all the values in our equation. There is a stress of 52.5 megapascal. There is a 350 kilonewton load, so 350 multiplied by 1000 divided by pi by 4 d square. That d we have to find. So if you find the d comes out 92.15. So 92.15 is a very odd figure. So let us make it suitable 95 mm. Now you can go for 93 mm, 94 mm also. That is also correct answer. But you should not go for 92. If you write 92 as a round-off value, then the stress becomes higher than 52.5 and the material will get failed. So that's why we must go to the higher side. So if there is a 92.15, that means go for 95 mm. 95 is more safer dimension for this particular problem. Okay, so this is one problem in which compressive stress we have considered. Let us have one more numerical based on same. Now there is a piston and cylinder arrangement. There is a piston having 300 mm diameter subjected to steam pressure of 0.7 Newton per mm square. So there is a steam pressure, it is not a stress. It is a pressure of 0.7 Newton per mm square. If the maximum permissible compressive stress on piston rod is 40 Newton per mm square, find the size of piston rod. So in this case, let us understand the problem first. Now look at this particular figure. In that figure, you will find that there is a bigger diameter D as a piston and smaller diameter D as a piston rod. So bigger diameter D is given as 300 mm in our statement of the problem. It is subjected to steam pressure. Obviously there is an inlet wall and the steam is enter inside that particular cylinder and it is going to push that piston so that there is a working of steam engine. So this particular capital D is subjected to pressure P, which is 0.7 Newton per mm square, and we have to find the diameter of piston rod which is connected to piston. So that is small d. So let us have given data. So as far as given data is concerned, pressure of 0.7 Newton per mm square is subjected on that particular piston area. The piston size is 300 mm and permissible compressive stress of 40 megapascal in the piston rod. So here, as we know, compressive stress is equal to force divided by area, but directly force is not given. How to find that force first? Once we get that particular force, then the force divided by area, we can find the diameter D, just like our previous problem. So for that, to find the force, here the force is the force on the piston, same force is carried away by the piston rod. So we know that the pressure is equal to force divided by area. So in that particular pressure formula, we have force divided by area. Same formula, same mathematical term we generally consider for our stress also, but the pressure is external and stress is internal resistance. That is the difference. Okay. Now here pressure is equal to force divided by area. Pressure inside that particular cylinder is 0.7 and area is having diameter of 300 mm. So pi by 4, 300 square will be the area. So let us see. Now force is equal to pressure into area. So pressure is 0.7 multiplied by pi by 4 capital D square. You just keep this in mind. Capital D, why capital D? Because the pressure is on that bigger piston. So from this we can get the force. The force is here 49455 newtons. So that much amount of force is given on that particular piston rod also, because that same force is carried away by the piston rod. So now we got force. We know the area of smaller piston rod is pi by 4 small d square, and the permissible compressive stress for the piston rod is given. So now we can have the calculation of piston rod. So how we can calculate that? So now we have force of 49,455 newtons. So we can have 49.45 kilonewton also, if I want to speak in kilonewton term. Now area is equal to pi by 4. Now here small d square. Stress is equal to force divided by area. Now stress, permissible stress is 40 megapascal only, which is compressive. Force is 49455 newton. Area is pi by 4 d square. We have to find small d. So small d comes out 31.15. So let us make it somewhat larger. So if you add material, if I increase the diameter, then force taking capacity or stress induced capacity is going to increase. So if I take 31, if I take 32, 33, 35, so whenever we increase the diameter, strength of that particular or stress induced capacity is going to increase. So that means 35 is the more safer answer. In our exam also, if you write 32 mm, you will get full marks. If you write 33 mm, also you will get full marks. If you write 35 mm, you will get full marks. That means here we can round off to next integer value, which is more safer. So this completes our problem based on compressive stress. So in the compressive stress, the same stress formula that we have considered, only thing is that compressive stress and tensile stress are equal and opposite, having same formula. So this complete numerical based on compressive stress.